Welcome to qnawire.
To solve this question, we have to calculate the magnitudes of the tensions T1 and T2. For that, we have to use Newton's second law. And I will use the following reference frame: a vertical axis pointing upwards and a horizontal axis pointing to the right. Let me call this X and the vertical axis Y. Then, we have to apply Newton's second law to the person. By doing that, we get the following. For the x-axis, the net force acting on the person is equal to the mass of the person times the acceleration of the person in the x direction. The person is resting there, so it's not moving and not going to move. Then the acceleration is equal to 0. So the net force in the x direction is equal to 0. But the net force in the x direction is composed by two forces. The x component of the tension number 2, so T2 component X, and the X component of the tension number 1, T1X. Notice that T1X points to the right, so it's positive, while T2X points to the left, so it's negative in my reference frame, and this is 0. Now, we can find a relation between T2 and T2X and T1 and T1X. For that, all we have to do is use the triangles that the question is giving us. One triangle is this one. So this is a 90-degree angle, and the other triangle is this one, where this is also a 90-degree angle. With these triangles, we can calculate the missing angle, this one and this one. It's easy to see that the angles inside the triangle should sum 180 degrees. Therefore, 65 degrees plus this angle must be 90 degrees. And then you conclude that this angle is an angle of 25 degrees. And also, doing an analogous calculation, you find that this angle is a 10 degrees angle. Now, you can decompose the tensions 2 and 1 to discover what is the relation between their x components and their magnitudes. We have to use other triangle for that. We use the triangle formed by the force and their components. So for T2, it's the following. It's a triangle like this, where the hypotenuse is the magnitude T2, this side is T2 component X, this side is T2 component Y. And we know that the angle between T2 and T2X is 25 degrees. So this is 25 degrees. Then, by using the cosine of 25, we can calculate the following. The cosine of 25 degrees is equals to the adjacent side T2x divided by the hypotenuse T2. Then, T2 component x is equals to T2 times the cosine of 25 degrees. Doing the same for T1, we get another triangle, which is this one. This is the hypotenuse, this is T1y component, this is T1x component, and we know that this angle is an angle of 10 degrees. Now, using the cosine of 10 degrees, we get the following information. The cosine is the adjacent side, so T1x divided by the magnitude T1. Then, T1 component x is given by T1 times the cosine of 10 degrees. Then we can use these results in this equation to get a relation between T1 and T2, and this relation is the following. T1x is equals to T2 component x. Then T1 times the cosine of 10 degrees is equals to T2 times the cosine of 25 degrees. And now we have one equation, but we are left with two variables. For the other equation, we have to apply Newton's second law on the vertical axis. For that, let me organize my board. So I will need these triangles again, so I'll keep them there. And let me do this calculation here. So for the y-axis, the net force is given by the mass times the y acceleration, which is also 0 because the person is resting. Then the net force in the y direction is equal to 0. But the net force in the y direction is composed by three forces: the weight force and the y components of the tensions. So we have the y component of tension number 2 and the y component of tension number 1. Then, as the tensions point to the positive direction, we have T2y plus T1y minus the weight being equals to 0. Then, T2y plus T1y is equals to the weight force. Then, for the y components, we can do an analogous calculation in the triangles, but using the signs in these two triangles. For instance, in this triangle, the sine of 25 degrees is given by the opposite side, so T2y divided by the hypotenuse T2. Then T2y is equals to T2 times the sine of 25 degrees. By the same reason, we have the following relation here. T1y is equals to T1 times the sine of 10 degrees. Then we conclude that T2 times the sine of 25 degrees plus T1 times the sine of 10 degrees is equals to the weight force. Now we have two equations and two variables. Let us solve them. So let me organize the board before proceeding. Okay, using the equation on the left, we know that T1 is equals to T2 times the cosine of 25 degrees divided by the cosine of 10 degrees. Then, using the other equation, we have T2 times the sine of 25 degrees plus T2 times the cosine of 25 degrees divided by the cosine of 10 degrees. This is T1, but I know from the other equation that T1 is given by this relation. And then we have to multiply T1 by the sine of 10 degrees, and this results in the weight force. We can factor T2, then we get T2 times the sine of 25 degrees plus cosine of 25 degrees times, notice that we have sine divided by cosine here, so this is a tangent, times the tangent of 10 degrees is equals to the weight force. Then T2 is equals to the weight force, which is 535 newtons divided by the sine of 25 degrees plus the cosine of 25 degrees times the tangent of 10 degrees. And this results in a magnitude of approximately 919 newtons is the tension number 2. Then we can go back to this equation to calculate the tension number 1. The tension number 1 is then given by 919 times the cosine of 25 degrees divided by the cosine of 10 degrees. And this results in a tension of approximately 845 newtons. And this is the answer to the question.